So this is Unit 2, Lesson 6 of our Precalculus 12 class. The unit is called Parent Functions. Parent as in your mom or dad. Lesson 6 is called Transforming Graphs of Radical Functions. What we're going to learn in this video is how to translate, stretch, and reflect a radical function. Translate moves the shape up, down, left, right. Doesn't change the shape of it though. The stretch does change the shape. The stretch will vertically stretch it or vertically compress it. And we can reflect the radical function over the y-axis, and we can reflect it over the x-axis. So if we add or subtract to a radical function, depending on where we add or subtract, it'll make it a different kind of translation. So if we add or subtract to the input, such as, you have the x plus or minus some number inside of the radicand, that's going to create a horizontal translation. And if we add or subtract something to the function, which looks like the square root of x, and then the plus or minus is outside of the square root, plus or minus some number, that's going to result in a vertical translation. So if we check that out on a graph, we have f of x equals the square root of x plus h plus v. As h becomes a positive number, so x plus some number, our graph is not going to change shape, but it is going to move to the right. And then as h becomes a smaller addition or becomes a subtraction, so x minus some number, the more we subtract, the further right this graph is going to move. And if we add something for v, if we add something outside of the square root, it's going to translate the graph up. Notice the shape has not changed, it just moves. And if we subtract from a radical function, it's going to translate the graph down. All right, so if we multiply our x value by some number inside the square root, such as square root of m times x, m being any real number, what we're going to do is we're going to increase the slope. We're going to do a vertical stretch, and we're going to increase the slope if m is some number bigger than 1. If m is between 0 and 1, we're multiplying by some fraction. It's gonna make a vertical compression of our function, and we can't say m is less than 0, because remember, this is a square root function. No, I take that back. You can't say m is less than 0. Now that I'm reading my slide, if you say m is less than 0, it's going to be a reflection over the y-axis, because that changes that takes the inputs for your function, whatever value of x, and you'd have to put it the negation of that, or the opposite, to make it work out. Because if m is negative, you can think of it this way: if m is negative, x has to be a negative in order for two negatives to multiply to be some positive number. And we want that to be a positive number, mx, because that's our radicand. Let's demonstrate that right here. So if we have m is 1, then we have just the square root of x being graphed right there. And if we make m a bigger number, we're going to vertically stretch this graph. It's like we're pulling the bottom and the top of the page away from each other. If m is less than 1 but greater than 0, we're going to smush this graph like a pancake. But when m is negative, we're going to reflect it over the y-axis. And so m equals -1 is the same graph as our original parent function. It's just reflected over the y-axis. If you think about it, if m is -1, then x has to be -1 in order for our square root symbol, or square root function, to be the square root of a positive 1. Be -1 times -1. So positive 1 in our red function maps to the same y value as -1 in our transform function when m equals -1. All right, so let's talk about how does r stretch it. So if I multiply the function by some number, so the number we're multiplying is outside of the square root, then whatever r is, the absolute value of r will be a vertical stretch of our graph. So r can be positive or negative. The further away it is from above 1 or below -1, it'll stretch our graph. If it's between -1 and +1, it's going to streetcar graph. And also, if r is a negative number, it's going to reflect it over the x-axis. So let's take a look at that right now. So if r here is a positive greater than 1, we're going to have a vertical stretch. If it's between 0 and -1, it's going to be a horizontal, it's going to be vertical compression. As soon as it becomes negative, now we reflect it over the x-axis. And then if it's less than -1, it's going to be a vertical stretch again. It's going to stretch that out. So we have M and R. M and R will determine which quadrant our graph is in. So right now, R is -1. If M and R are just both positive, we're going to be in quadrant 1. But if R is negative, as you just saw, we'll be in quadrant 4. And if M is negative as well, now we're in quadrant 3 because it's being reflected over the x-axis and over the y-axis. But if R is positive and M is negative, now we're in quadrant 2. And if we make them both positive, we're in quadrant 1. And then we're in quadrant 4 again, and then quadrant 3, and then quadrant 2, and then quadrant 1. And then we're in quadrant 4, and then we're in quadrant 3, and now we're in quadrant 2, and now we're in quadrant 1. And I could do this a lot, but I'm not going to anymore because we got to move on. Takeaways for this lesson. We now know how to translate, stretch, and reflect a radical function.